Get ready for a thrilling AI update. Microsoft has introduced Visual Chat GPT, an advanced tool that combines Chat GPT with visual foundation models. Excitingly, users can now effortlessly share images during their conversations, a feature long awaited by many. With its remarkable multimodal capabilities, the upcoming release of GPT-4 adds to the anticipation. Stay tuned for all the exciting details. Visual Chat GPT builds upon the exciting capabilities of Chat GPT 3.5. Now upgraded to GPT-4 by enabling the exchange of images alongside text-based messages. The research paper accompanying the release of Visual Chat GPT provides a detailed understanding of how the tool works. It highlights the foundational models that form a basis: Blip, Stable Fusion, Pix-to-Pix, and ControlNet. These models work together to enable a range of functionalities, including image-based queries, iterative reasoning, and image manipulation. The paper offers several examples to demonstrate the potential applications of Visual Chat GPT. For instance, it showcases the tool's ability to generate images of cats or dogs based on users' requests. This means that users can simply ask for a picture of a cat or dog, and the tool will provide a visual representation accordingly. Visual Chat GPT can also modify existing images by replacing objects or removing elements. This feature allows users to manipulate images to suit their needs. Furthermore, the tool can perform image-based tasks such as generating the canny edge of an image. This demonstrates its ability to effectively process and respond to textual and visual prompts. By enabling image sharing within conversation, the tool opens up new possibilities for richer and more engaging interactions. Users can now seamlessly incorporate visuals into their discussions, enhancing the ability to convey information and express ideas. The underlying models of Visual Chat GPT play a crucial role in its functionality. Blip, which stands for Bidirectional Latent Information Projection, facilitates image-based queries by mapping images and textual descriptions into a shared space. Stable Fusion combines information from different modalities, such as text and images, to create a coherent representation. This fusion enables the tool to process and reason over multimodal inputs effectively. Pix-to-Pix is another foundational model used in Visual Chat GPT, and it is instrumental in image manipulation tasks. It's a generative adversarial network, GAN, that learns to transform images from one domain to another. ControlNet, the final foundational model, aids in iterative reasoning. It allows Visual Chat GPT to build upon previous interactions and refine its responses over multiple exchanges. With Visual Chat GPT, Microsoft has addressed a significant need within the AI community by incorporating visual elements into conversational AI. This tool marks an important step in enabling more natural and comprehensive interactions. Combining text and images seamlessly enhances the communication experience and opens up new possibilities for various applications. In recent demonstrations, it showed an image generated by software that attempted to depict a cat running in a garden. Although the image wasn't an exact representation, it exhibited characteristics of Stable Diffusion. It speculated that other software could potentially incorporate additional features like mid-journey generations in the future, then tested the software's ability to accurately describe images. They provided an image of Jack Kilby, an American electrical engineer, and asked the software to identify him. The software successfully described the image as a man wearing a suit, tie, and glasses. However, it failed to provide specific details about Jack Kilby's identity. It assumed that the lack of Facebook recognition services might be the reason behind the limitation, as privacy concerns surrounding such features are prevalent. Despite the limitations in image recognition, the software could generate images. It gave an example where they asked the software to generate an image of a cat running in a garden. This time, the generated image appeared more realistic than the previous attempt. Satisfied with the generated image, it asked the software to remove the cat from the picture. The software successfully fulfilled the request and provided the modified image without the cat. Taking it a step further, it noted the bright pink flowers in the modified image and asked the software to change their color to yellow. Once again, the software delivered and presented the image with a yellow flower instead of the original pink one. While the software demonstrated its image generation and modification capabilities, the IT speculated on the future development of similar technologies. They pondered whether Microsoft, the company behind the software, would invest in further upgrades and advancements. It was suggested that the current software might be a mere demonstration to showcase the possibilities, even though the underlying GPT-4 model was not multimodal. Despite this limitation, it emphasized that there were still workarounds and methods to achieve desired outcomes through other means. The paper delves into the limitations of a technique known as Visual Chat GPT in the realm of multimodal dialogue. It sheds light on several drawbacks that should be considered when employing this approach. One of the key challenges lies in the heavy reliance on ChatGPT and visual feature modules, VFMs. The accuracy of the output heavily hinges on Chat GPT's ability to accurately identify and assign tasks to VFMs. Inaccuracies in this process can have a detrimental effect on the quality of the output. Additionally, the technique necessitates careful construction of user input, which can be daunting for individuals without expertise or those who struggle to provide appropriate prompts. Another significant limitation highlighted in the paper is the substantial time and expertise required to convert VFMs into language descriptions that the model can comprehend. This conversion process involves a combination of computer vision and natural language processing knowledge. Consequently, visual ChatGPT can be time-consuming and may demand specialized skills. Furthermore, the technique exhibits limited real-time capabilities. Applications that require immediate responses may not be well suited for visual ChatGPT. While the method can still be valuable in certain scenarios, its effectiveness may be diminished compared to real-time systems that swiftly process and respond to inputs. It's essential to comprehend that visual ChatGPT does not serve as a replacement for the multimodal features of GPT-4, despite some users mistakenly assuming so. OpenAI has clarified that they do not currently provide the specific service of utilizing GPT-4 with images. However, they have expressed their intention to inform the community when such features become available with the release of GPT-4. To provide further clarity, let's delve deeper into these limitations. The success of visual ChatGPT depends on the smooth teamwork between ChatGPT and VFMs. If there's any issue with their collaboration, the results may not be as good as they could be. Users should craft clear and well-structured prompts to get good results from visual ChatGPT. This can be difficult without expertise, as it requires understanding the model's limits and how to extract the desired info. Success depends on coordinating between ChatGPT and VFMs, so having the right knowledge and skills is crucial. Additionally, the conversion of VFMs into language descriptions that the model can comprehend requires a considerable amount of time and expertise. This conversion process involves translating visual information extracted by the VFMs into a format that the model can understand and process effectively. It requires a combination of knowledge of computer vision technique and natural language processing. The expertise in both domains is essential for accurately representing the visual features in a language format that can be seamlessly integrated into the multimodal dialogue. This process can be time-consuming and may necessitate specialized skills, limiting the accessibility of visual ChatGPT to a broader range of users. Furthermore, the real-time capabilities of visual ChatGPT are constrained. While the technique can provide valuable insights and responses, it may not be suitable for applications that require immediate or real-time interactions. The process of coordinating between ChatGPT and VFMs, along with the necessary computations involved in generating responses, introduces inherent delays. In time-sensitive scenarios such as live conversations or dynamic environments, the limitations of visual ChatGPT become more apparent. Real-time systems that can quickly and efficiently process and respond to inputs may outperform visual ChatGPT in these contexts. It's crucial to dispel the misconceptions that visual ChatGPT is a replacement for the multimodal features of GPT-4. Some users may incorrectly assume that GPT-4 provides comprehensive support for images-based inputs. However, OpenAI has clarified that they do not currently offer the specific service of using GPT-4 with images. They have expressed their intent to inform the community when such features become available upon the release of GPT-4. Until then, users should be aware that the capabilities of GPT-4 in handling multimodal inputs, specifically images, may not be readily accessible. In conclusion, the paper sheds light on the limitations of visual ChatGPT, urging us to consider its dependencies, prompt engineering challenges, time-consuming processes, real-time constraints, and the misconception about GPT-4. As we explore the potential of this technique, it's crucial to be mindful of these factors. Like, share, and subscribe for more insightful content.